In this video, we're going to be looking at naming and drawing primary amides. Amides themselves are a very important functional group, both biologically and industrially. Amides contain the functional group COONH. Here is the carbonyl group, and with the nitrogens, and you can have either hydrogens or alkyl groups coming off the nitrogen. These all represent primary amides, where the amide group is on the first carbon. So this would be methanamide. This one here is the amide group. That would be carbon number 1, 2, 3. So this would be propanamide. And this one here, there's the amide group, 1, 2, 3. So that's B propanamide with a 2-hydroxy. So the amide group is on carbon number 1. Amides can be classified according to the number of alkyl groups attached to them. So if you have got an amide group, which looks like this, if it's got 2 hydrogens attached, that's a primary amide. So the primary amide is like that. A secondary amide has got an alkyl group attached to it. So it's got 1 alkyl group attached to the nitrogen. So a secondary amide would look like this. For example. And a tertiary amide would have the 2 alkyl groups attached. So it would look like this. And this would be an example of a tertiary amide. In our course, we will only be looking at primary amides. We have some examples of primary, secondary and tertiary amides. So they are all methanamides because there is 1 carbon attached to the carbonyl group. So this makes them all methanamides. So every single one of these is an example of a methanamide. Now, this has got 1 methyl group attached to the nitrogen. So you go, that's telling us it's attached to the nitrogen, N-methyl methanamide. This too, because it's only got 1 carbon attached to the amide group, is a methanamide. But this time we've got N, N, which means attached to the N we've got 2 dimethyl methanamide. As I said, we will only be studying primary amides. So let's go through how to name a primary amide. Name the parent compound and find the longest functional group it's attached to. Now the amide group will always be in the lowest position, and you write the suffix amide. You don't have to put a number in. Name any substituent or alkyl groups present, and name any groups in prefix. So here is our amide group. So that is carbon number 1, 2, 3, 4. We have a methyl. We have a hydroxy, which goes to prefix. And we have a bromo, which is in prefix. So it is butanamide. You have a methyl group, which is a substituent or alkyl group, and that's on carbon number 2. And then you have a hydroxy and a bromo. Hydroxy is after the bromo because of alphabetical. Hydroxy is on carbon number 3, and bromo is on carbon number 4. So 4-bromo, 3-hydroxy, 2-methylbutane amide. Try naming these primary amides. You're going to need to stop the video and then restart it. So this one has got 1 carbon group, so it's a methanamide. Stop the video and have a go at naming. So this is carbon number 1 because of the amide group, 2, 3, 4, so it's butanamide. And on carbon number 2 we have a substituent or alkyl group, which is a methyl group, and it's on 2-methylbutanamide. Try the next one, stop the video, have a go. So here is our amide group, so that's carbon number 1, 2, 3, 4. We have a hydroxy group in prefix, and then we have a methyl group and a methyl group. So it's butanamide. You don't have to number the amide group, it's always number 1. And we have 2 methyls, so it becomes dimethyl, and they are on carbon number 2 and 2. And we have a hydroxy group, which is on carbon number 4. 4-hydroxy 2,2-dimethylbutanamide. Now we're going to try and draw some primary amides. So first of all you draw the parent chain, so in this case it's butanamide, so 1, 2, 3, 4. Put the carbonyl group and the amide group on. On carbon number 2 we have a methyl group. On carbon number 3 we have a methyl group. On carbon number 2 we have a hydroxyl group. And carbon number 3 we have a chloro group. Complete the drawing by putting in the appropriate number of hydrogens. Now try drawing these primary amides. You will need to stop the video and have a go. Start with the longest chain, the parent stem. So it's propanamide, so 1, 2, 3. Put your amide group on, and then methyl, and then put the appropriate number of hydrogens on, so that each carbon has 4 bonds. Next one, 2,4-pent means 5. 1, 2, 3, 4, 5. Put the amide group on, and then 2,4 is dimethyl, so put the appropriate number of hydrogens on so that each carbon has 4 bonds. The last one, butanamide, 1, 2, 3, 4. Put the amide group on. On carbon number 3, 1, 2, 3, we have a methyl group. On carbon number 2, we have a chloro group. On carbon number 3 we have a chloro group, and carbon number 4 we have a hydroxyl group. Complete by putting the appropriate number of hydrogens on. I'd like you to try some yourself. Go to the OneNote Organic Amines and Amides and complete the nomenclature exercise on amides. Good luck.